Are we live? We are live. Sweet. We'll give it a minute, see if anybody pops in. Yeah. Maybe wait for one viewer. That'd be great. So while we're waiting, we're going to be talking about the plyWith function. plyWith. 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 Oh, I don't have a flood function. All right, let's get the flood function. Replicator. Nobody's watching yet, so I can do this. I have to flood the text correctly. There we go. plyWith. We're going to talk about plyWith. All right, nobody's around, but that's okay. Nobody wants to hear this weird music anyway, right? Oh, I never changed my stream title. TidalCycles, plyWith function. Update. All right. plyWith. Okay. All right, so we're going to talk about plyWith. plyWith is pretty cool. It was introduced in a recent update, the latest release in TidalCycles. We'll go to GitHub. If you look at the release notes, the changelog, I should say, there's a new plyWith function in 1.4.3, which you can get if you update. And it is pretty nuts. So plyWith, what it does is extension of the ply function. So ply, if you've got a pattern like this. By the way, if the levels are kind of wonky, let me know and I can adjust them. So plyWith, or ply, will repeat an event the number of times that you put in. So ply3 will play 3 BDs and then 3 CPs. Like so. By the way, you might hear a piano in the background. Nothing I can do about that. You can also use a pattern for this. So if you want to play BD 3 times and then CP 5 times, you could do ply with a pattern that matches your sound pattern. So that's pretty cool. And I'm just gonna make something up here. So 1, 2, 3, 4. Okay, settle down. It's maybe not the best example. So you can then take ply and then you can pattern it out. So you get these weird stutters. So ply will repeat every event in your sound pattern this number of times. So one cycle, everything gets repeated 3 times. Another cycle, it gets repeated every 5 times. So it's kind of a very fast way to create like these stuttering or ratcheting type patterns. So that's ply. But plyWith takes it to a whole new level. Like right about eye level, right there. Takes it to a whole new level. So plyWith is similar, where you can specify a number of repeats, but then you can also give it a function to apply to your pattern. So if I say plyWith for ID, ID will just not have any effect. It's like returning the same thing that's already happening. So these two patterns are the same. plyWith ID, or plyWith for ID, is the same as just ply_for. So here's ply_for. plyWith for, same thing. So then, identity function, yes. But you can put whatever function you want in here. So if you want, you could do like reverse or something like that. But I think it's better to think of it as a function you want to apply to every repeated note. So if you do something like gain 0.8, it will play every repeated note at a lower volume. Like that. Or you can do something like speed. And you can, of course, do any amount of complex thing in here that you want. You can also do, instead of the pound sign to just assign the value, you can also do the multiplication pattern combiner, which is a pipe splat or pipe asterisk. And if we do speed 1.1, this will increase the speed by 10% on each repeated note. Let's do RB so you can hear it better. So again, on each repeated note, I've got this function being applied. So it's multiplying the previous played note by a speed of 1.1, which increases the next note's playback speed. And you could do the same with gain. So if I wanted to decrease the volume, you can do that. You could even, I wonder if you could even if you could nest these. What if you do apply inside of plyWith? Yeah, you can do that. You could also shift time around, I suppose. So if we do yeah, so in this case, I'm just moving time around. So you can put anything you want in here. But the way I've been approaching it is with some kind of extreme, kind of like granular, almost audio rate type stuttering, and also combining it with tempo changes, which is kind of weird, using CPS. So what I've been doing is, if I get like a pattern going here, I'm going to change my dirt samples are overriding my custom ones, which is kind of bothering me. So I'm going to change that back. So if I just get some kind of pattern going here, I don't know what this is going to sound like exactly. Hold on. Let's slow that down. So now if we do plyWith and then like a large value like 10, actually I'm going to make this even slower. I'll do set CPS 0.4 maybe. So kind of a slow thing, and then if we do plyWith 10, something like this, where every stuttered note is 80%. Sounds kind of wonky. If we want, we can change the number of stutters every cycle, like this. I think. Yeah, okay. My end pattern, which was set to run 10, was actually causing the sample to change within the stuttered values, which I didn't want. So now if I force the sample to be locked in every cycle, so now that ratcheting effect gets held every step. Where'd my chat window go? There it is. It's important to chat. Okay, so what I've been doing is then kind of combining this with changes to cycles per second, which is kind of nuts. So I think we're at like 0.4 right now. But you can make this whatever you want, right? You are welcome. I love keeping Tidal alive. All right, so this is kind of a weird, like, I don't know how you describe this. It's a meterless, tempo-less approach. There's not really a defined tempo because we're changing it every cycle with CPS. We're patterning it out. So one cycle it's 0.4 cycles per second, then 1 cycle per second, then a quarter cycle per second, then 0.8 cycles per second. And then that pattern is kind of wrapping and being combined with the plyWith. So we get these different repeat amounts. And then we also have a different sample being played every cycle. And I like to have these in different quantities. So we've got we have a sequence of 4 different tempos, 5 different samples, and 3 different stutters. So everything just kind of twists and kind of turns upon each other. It doesn't sound the same very often, which is my kind of thing. And let's put a clap in there. We want to ground this thing with a clap because we can. Yeah, everything is relatively prime. That's a good way of explaining it. Yeah, it'll repeat in 12 times 5, 20 times 3, so what is that, 60? Yeah, so in 60 cycles it'll repeat. I love it. So let's do we'll put a clap in there. All right, so now I've got this long reverb clap every cycle. Let's change this to every 2 cycles. And you know what? I'm going to change the sound so it only plays once every cycle as well. So this is going to be a lot slower. I have no idea what I'm doing. This is just fun. All right, so what else can we do? So another thing that you can do is or that I've kind of been messing with is modifying the, actually before I do that, let's see what it sounds like if I multiply the gain. So now it fades out on every stutter. This clap pattern is totally unrelated to what I wanted to talk about, but that's okay. All right, we're gonna take the clap out. It's distracting. It's fun, but no, that reverb is baked into the sample. So that reverb is on the sample itself. This is a sample I made. If I truncate it, you can actually hear it's baked into the sample. Yeah, so that's not the Super Collider or Tidal reverb. Good question. The cool thing, I'm gonna get off topic now. So the cool thing about baking reverb into samples is that then you can really mess with the reverb effect as kind of like this sustained sound. So if I do like, I can granulize it. So I'm actually chopping up this reverb into 64 pieces and slowing the pattern down by 8. And every slice, every 64th of a slice, or I should say every slice, which is a 64th of the sample, is now its own unique note event. So this is like playing a pattern of 64 individual notes. Anyway, that's a diversion there on if you bake reverb and bake stuff into samples like that, you can have some fun little side effects. All right. Let's increase the plyWith. Let's add some more ratcheting. So when you fade out the gain like that, you can also sometimes, let's do every 3 cycles, we'll reverse it. So now the gain will fade in every 3 cycles. Or we could do just randomly some cycles rev. So 50% of cycles will, at random, will be reversed. So when you got your gain going on like that, that's kind of fun. The other thing I've been playing with is messing with legato. So let's play with legato. I need a good sample. What's a good sample? Let's go to my samples folder. By the way, if you're using the VS Code extension, which is what I'm using here, there's a new feature being developed by another person that's going to allow you to browse samples right in the editor itself. It's kind of a new fun thing. Okay, so let's go. Oh yeah, we've got a chord in here. Great. All right, so there's our chord. So let's do plyWith 10, and then let's really slow this down. What did I do? What did I do? Oh, I didn't specify a function. So we'll decrease the volume on every stuttered note. Okay, so we've got our kind of our chord, and we are repeating it 10 times every cycle. I'm just playing it once per cycle. I don't know if this is too much detail, but here's the pattern by itself. And now if I add the plyWith back, we get that. So Legato. Legato is, I think, an underused feature of Tidal. So Legato will set the duration of the note event within the cycle. So Legato 1, let me go back to a simple example here. So let's make sure our CPS is set. So we've got a simple pattern. If I just say Legato 1, it's, even though the sample itself is short, it's the time of the whole event is a full cycle. If I say Legato 0.5, it's only filling up that sample for half a cycle. If I do 2.25, the note event will only be a quarter of a cycle. And we're still not hearing anything because the sample's too short. Eighth of a cycle. And now you can hear it getting truncated because the note event is now shorter than the sample. If I do a 16th of a sample, or a 16th of a cycle. Yeah, this is also a nice MIDI feature to control how long a note is held down. That's I guess the way to think about this is how long if you were playing this sample on a keyboard, how long is it being held down on the keyboard? Okay, so this pretends, Legato 1 is like holding the sample key down on a keyboard for a full cycle. So let's go back to our plyWith this. So when you do Legato 1, then each stuttered note, basically Legato 1 means every stuttered note fills up a 10th of a cycle because there's 10 events being fired. Then Legato 1 means only fill up the division of space. If I have 4 chords, Legato 1 means every chord is only going to be a quarter of a cycle. So it just means fill up evenly the space divided by the number of events. In this case, it's 10. So Legato 1 means a tenth of a cycle for each chord. If I remove this, you'll hear the chords bleed into each other. And here's with Legato on. So it truncates samples by making sure they don't play past their unit of time. The cool thing is that we can modify Legato with a function. So we can say on every stuttered note, make the stuttered note half the length it would normally be. I'm going to decrease the volume of this too. Or you can multiply legato to make it shorter. Each stuttered note gets shorter. Which I think it sounds really cool. And then as you put more and more notes in, more and more stutters in, it has kind of a more dramatic effect. Is the last legato overriding the first? So I'm not sure what you mean by the last. So this legato 1 is kind of the default in the pattern, and then this legato per stuttered note will be multiplied against the previously played note. So if the first one is 1, the next stuttered note would be 0.9. The next one would be 0.9 times 0.9. The third one would be 0.9 times 0.9 times 0.9, and so on. Hopefully that makes sense. So we're continuously multiplying or diminishing or shortening the length of the legato, continuously multiplying it by 90%. And then if you combine this with like a kick drum on in a stack, if you've got the right sounds, this is it sounds great. So I'm just going to copy this pattern here. And we'll give this a kick drum. Take legato out of the kick drum. No, what did I do? Oh, $sign. All right, here we go. Oh, let me take the legato out of the kick drum here. Anyway, so you get these really cool kind of computery, and it sounds like music that a computer would come up with, I think. I don't know. Or a human. I don't know. I'm human, I guess. I came up with it, so it's human music? Human computer music? I don't know what I'm trying to say. All right, so this is cool. And then, you can put that legato back in here. And then, of course, you can put CPS patterning on top of this, which makes it just super fun. Just picking random numbers. Yeah. All right. So another thing that's kind of neat is that plyWith kind of came from. I think internally Ply uses like an arpeggiation technique, and plyWith is kind of derived from that same base. So you can actually get some arpeggiation type effects with plyWith. So if we go back to our chord here and do something simple, we'll just do ID. If you then put, let's do like up and 0, this keeps the pattern the same here. So up is kind of a simple way of setting the note number You could also do this with, I think, note C5. Yeah, we'll use that. This is more of the accepted way of doing it. So C5 is kind of the root of where samples play, but if I want, I can create a pattern of, think of it like an arpeggiator. So I've got C5 and then the next note up, D5. plyWith will actually double or play the second note after this first one. So instead of playing them together, it'll play the first and then the second. So all it's doing is it's changing the playback speed of the sample. We're not really playing any MIDI notes or anything like that. But the point is, it will play the second note in your pattern here. If it's separated by a comma, it'll play the second note kind of like an arpeggiated way. So that's kind of interesting. I think it's also kind of fun to do this with different samples. So if you want, like, if we had a kick drum, let's change this up a bit. And you can also create a pattern of different samples. So if I wanted like a hi-hat, you can kind of get some stuttering percussion that way. So that's kind of interesting. If you don't put the comma in, I forget what it does. Oh yeah. So then it treats it as two separate note events. The first half of the cycle, then the second half of the cycle. But if you combine them together, it'll you'll get that kind of arpeggiator type style thing. All right. What else we have here? If you have any other questions or want me to try something, let me know. What else was there? There was something else I was going to show. Maybe not so much plyWith. I think that's about all I've really discovered with plyWith, but this is ridiculous fun. Oh, combining striate with plyWith. So I've done some videos long ago about extreme granulization with striate, but you can also achieve extreme granulization by layering two functions that produce a lot of events. So plyWith can produce a lot of events, so can striate. So I don't know, I'm just going to make this up. So let's try I think this will work. All right, so I've got kind of like a four 4-bar loop of a sample, and I'm just chopping it up into 128 pieces. Each piece is 1/100th of the original size, and then slowing down the whole thing by 16. So you can put a plyWith on top of this, and I think every grain or every little chunk of the sliced sample then gets stuttered or repeated with plyWith. So if we do something like this, I don't know, I'm just making this up. Oh, did I crash Tidal? No. All right, so hopefully that's coming through okay on the stream. So I'm taking this granulized sample, or this stretched sample, granulized, and then every grain is then being stuttered by, it's being repeated 2, 4, 8, or 6 times, and each time the grain has a lower volume of 90%. So yeah, you can kind of go nuts. And a lot of this stuff is patternable, so you can change like how many slices there are per cycle. Granted, this is being slowed down by 16, so I don't think this will change very often. Yeah, who needs a clouds module when you've got TidalCycles, right? I don't know. Clouds is cool. I'm not hating on clouds. I like clouds. What else? So yeah, you can layer stuff on top. When you start combining this with like some percussion and some of the CPS changes, let's just do that. This is my weird indentation style, sorry. You just have to deal with me. Yeah. Let's just see what this sounds like. No. Do I have an error? I must have an error. What did I do? S supplied too few arguments. What? What did I do? What is... Oh, dang it. There we go. Need a function for plyWith. All right. I don't know if that sounds very good, but yeah, thanks. Got it. So if we do... Now if we change CPS in the middle of all this... And then heck, you can modulate CPS inside of itself. So we can multiply this. So we have CPS changing per cycle. We can modulate it with a sine wave, because why not? So what we're doing is we've got our CPS pattern, which is discrete values of time per cycle, and then I'm multiplying that times a scaled sine function. So I'm multiplying all of these values by a sine function that's oscillating between 0.5 and 1.5. Because this CPS is at the end of the pattern, I'm not going to be able to explain this very well. Because it's at the end, you hear kind of these stepped changes in tempo. It's just once per cycle. But if we move this up above the stack, it's more fluid. That you do it like this, then this sine wave will be, I guess, sampled every grain of this striate, and we'll get more continuous tempo changes. You'll hear the ramp up and the ramp down more often. Take the kick drum out of there. So you can, it's kind of cool. So with this granulated sample, this loop, you can kind of hear those ramps a little bit if you listen closely. You hear that? But why stop there? Why slew it by one function when you can slew it by two functions? So you can do this. We can actually have it go even something like this. All right, now I'm changing topics. Now we're getting into CPS changes, but that's okay. Let's do that. plyWith 10, 20, 15. You get the idea. I love this sort of thing. So combining CPS changes and plyWith, you get this very fluid, granular these fluid granular types of systems or something. I don't know what you call them. Yeah, so I think that's about all I want to show. I thought I might be doing this for a couple hours, but that's about it. Maybe I'll just play around for a bit more. Please feel free to ask questions. Yeah. Let's see, what can we do here? Work well for MIDI control. Yeah, you could certainly pattern out MIDI control changes with the CPS approach like this and get like these oscillating control change style modulations. Certainly doable. All right, so let's see. What other samples do I have here that we could play with? Maybe. I just want to take a look. What do I have to work with? We got lots of stuff. Just trying to refresh my memory. What we got. All right. I don't know. Yeah, I don't know. I don't know what to do. We'll start with a hi-hat. We like hi-hats. Oh yeah, we've got a pony sample. I do have a pony sample. All right. That's a great suggestion. Bonus points if you can figure out what the movie is. I have to slow it down so you can hear it though. I do this kind of crap every day, and my family just, they don't understand. Let's put some reverb in here. What's going on? Oh, it's too quiet. All right, let's take a break and answer a question. What are the less than, greater than brackets for? So this allows you to set values per cycle. So let's do this. If we do S, and we'll do just a bass drum pattern here. If I do speed 1, if I wanted to change the speed of the bass drum every cycle, I could use angle brackets. So if I want one cycle to be 1 and then another cycle to be 2, I could use this. First cycle. Let's speed this up a bit. So this pattern is equivalent to this. So I'm slowing this pattern down to be 1 value per cycle. And if I wanted it to be 3 different speeds, change the speed once per cycle, it's the same as doing this. So it's kind of a shorthand way of just saying only change the value once per cycle. So that's where this is here. So it's changing the tempo once per cycle, and these plyWith values are also changing once per cycle. Yeah, the modulus 1 also would do it. I did that right. Move the cycles per second up. Would you buy this music? All right. Another interesting thing that I've been trying to play with, but I haven't really noticed a good effect, is to use, or really noticed it having an effect, is linger. So linger will repeat a section starting at 0 time of the cycle. It will repeat a portion of the cycle. So if you do linger 0.25, it'll play the first quarter of a cycle and then repeat it for the rest of the cycle. So it'll play the first quarter of a cycle 4 times. But damn claps don't know when to stop. So I've got so much going on in here. And honestly, I think the CPS oh, my headphone just came off. I think the CPS patterning is probably messing up how linger chooses what events to take. Anyway, that's a linger is another function for a different video. All right, well, we'll stop there. I see my video stream is a bit unstable. I think the bandwidth in my house is being shared and competed for at the moment. So we'll just end it here. Thanks for tuning in. I hope you enjoyed the plyWith function. It's nuts. The pianist won. Yeah, you know what? The pianist stopped practicing piano and went and watched YouTube and consumed all the bandwidth. That's the problem. All right, so yeah, okay. All right, thanks for watching. Go check out the plyWith function if you want to see the documentation. It is, I don't think there's any, yeah, there's documentation. We'll go to TidalCycles.org, search for plyWith. We don't have a plyWith doc out there yet, unfortunately. You know what? We need to create one. We'll do that now. Should we do that right now? Let's do that right now. No, we're not going to do that right now. We need to end this, save the bandwidth. So, all right. Thanks for tuning in. I will, I'll see you in the future, if not later. And until then, I don't know. I don't know how to end this. All right. Thanks. See ya. Bye.